Here's an example problem that's pretty similar to one of your homework problems. I thought it was a little bit difficult, so I'd go over it. Alright, so we got here a rod, and its mass is big M, and we want to figure out how long it has to be in order for the moment of inertia of this rod and two ball system to be 0.967. And we're told that the length, or the mass of the rod, that big M, is 4.17. Both of the little balls on the ends are 0.547 kilograms, and what we're trying to solve for is the length of the rod. What we want to do here is to come up with an equation for the total I value of this system, and then set it equal to the 0.967. What we know we can do is we can sum the different components here. So we'll just add up. We can say that I is the 0.967, and we can set that equal to what we know the what we know the expression for the I for the balls is, which, let's see, each ball would be at the complete outer point from the center of motion here, from this axis of rotation. So all of that mass is going to be on the outside. So we don't have a fraction times mr squared. We just have straight up mr squared for each of those two balls. So there's because there's two balls at each end, we have 2 mr squared. And to that we add the moment of inertia for the rod, which, because it's rotating about an axis in the middle of the rod, is 1/12 of its mass times its length squared, because rods are different. They have the equation is in terms of the length of the rod. So L here in this equation is the variable we want to solve for, and we don't know R, but we do know how it relates to L. We know that this R distance is half of the length of the rod. So instead of putting R there, let's put half L. And then we would square the half, and that becomes a quarter, and the L is squared also. And then 2 times a quarter is 1/2. So for this term we'd get 1/2 ml squared. And over here we'd still have 1/12 big M L squared. So our equation would become this. And what we want to do is combine these L's, or get it so that we only have one L present. And we can do that using this trick. So we just write that a little bit differently. And then we see that we can just divide both sides by half little m plus 12th big M. Alright, I'm running out of room, so we're going to come back up here. And this is what we get after dividing both sides by the half m plus 12th big M. And we've almost solved for L. We solved for L squared, so we just have to take the square root of both sides. Square root of this equals L. And then we can put in the numbers that we know for the masses. Little m is 0.547 kilograms. Big M is 4.17. And there we go. And now it's just a matter of getting our calculator to tell us what the answer is. And see, I got L equals the square root of 1.55. And the square root of 1.55 is 1.25. And that was in meters. because we stuck with SI units the whole time.